or to cloud. Sweet. So knowledge graph team sync here. So let's just jump into it. So like we met before, John Michael and I met before, and we went over some of the design as far as like how we're going to design it. And then also we've been working on some of the parser initial implementations. So we'll talk about that in a little bit. But first want to do a little bit of a demo because this is basically the first end-to-end, I don't know, working version, working with strong emphasis, like definitely work in progress. Um, but yeah, first working version of the knowledge graph with like our chosen tech stack. So yeah, I'll just show you guys directly. So let me delete some stuff. So this is the output. So I'll delete this output folder. And this is where the actual Kuzu database is stored. Um, and I'll do a fresh build. So I'll do cargo build release CLI. And just so you can see here, we've got a CLI, and the CLI takes in a database path or an output path. But the first thing it takes in is the workspace path. So we can index multiple repositories. I'm not going to show you that right now because I actually haven't verified that works too well yet. But again, the goal is you just point to a workspace, and because this needs to work in the language server, you point to a workspace folder and it indexes everything inside of it. And then it'll persist the data to like the appropriate database folder. And we'll need to talk about all of that stuff because there's a lot of like tech stack management things we need to work on. But yeah, so this is this CLI here. And then all the indexer code is written here. And the code is built off of the two MRs that we have up for review right now. Um, Again, this is very like a much of a hack version, but it's working end to end. So I'll show you guys a command here. I think it's if I do rust log. So I'll set the rust log to info. I'll run the CLI, and then I'll point to my project. In this case, it's doing Ruby files on the monolith. Um, so it's around 40 something thousand files. And this is using the production binary. So this is like the quote unquote true speed for this particular machine. Might be slower on, say, Windows, give or take. But so we'll go ahead and run this. And right now it's going through the parsing phase. So like actually extracting the definitions from each file. And then you just saw there, it went through, I'll go back. It went through the analysis phase, just like basically like one-to-one with the design. So this is the analysis phase here. And then once it does that, it writes it to the Parquet files. So you can see in the output here, we got all the different relationship types. Michael's probably like, this is way too messy, so we'll figure out how to make this prettier, of course. This is just, again, getting it working. And then from there, I'm executing all the Kuzu related Cypher queries. First to actually create the database from scratch. I removed the old database for now. We're going to need to, again, go over a bunch of the database management stuff. But then it goes through, creates all the tables, using a lot of the stuff that I learned from the research agent stuff, and creates the relationships. Then it goes through the actual Parquet files and imports, takes the data and bulk loads them, like by executing the Kuzu queries. So you can see it's like importing relationship data, class to method as an example. And then once it does that, it'll, say it's successfully processed. So in this case, we did it in 9 seconds. We did how many definitions here? 162,000 definitions, 200K relationships. This is only capturing definitions, right? Oh, actually, here the amount of total nodes. So this is including files and all the other type of nodes. Like we said, it's like we agreed on, it's only capturing definitions. So it's basically a giant tree. It's not really anything graph yet. But yeah, so that's what's happening here. So we went through 40 something thousand files, got all the definitions, got all the relationships. These are only the Ruby files. So yeah, it's pretty fast for at least this machine. And then if I do Docker and I load up uh, Docker with the file database. Um, oh, it's already loaded. Let's kill that just in case. Let me just kill it real quick. Because I'm pretty sure when you spin up their playground, it loads it back into memory. I just hope I don't. I hope I don't. Let me cancel. I have so many. I have a bajillion tabs. Sorry, guys. Um, I hope I didn't lose all the queries when I just did that. But I did lose them. That's unfortunate. Dang, that's what I was hoping I didn't do. But we can recreate them. So let me go back just to show you guys. I'll just like pick the first few nodes. So we'll take this basic cipher query here, just query like the first 10 nodes. Actually, let's do 100. And we run this. So this is the monolith, right? And then of course, like we have all the directories, which are like imported first, right? So in this case, there's app models. We can see the different relationships. I don't know if you guys can see this that well. Let me make it like bigger. I don't think you can actually make this bigger. That's annoying. But yeah, so we have here all the directories, right? So pretty basic stuff. But then we can do something like, what is it for matching a particular node? I'll just steal this query. We can do something like this, where we match on, um, uh, let's do definition, and we'll do definition node. Why isn't it giving me, it should be giving me like IntelliSense. I think we can just do definition. I'll just do definition now. There we go. What was the syntax again? Sorry. Um, user return. Um, so let's do def. Yeah, I think we can do that. And then I think we can do query by the FQN. And in that case, let's open up the GDK. Let me go into GitLab. I need to like pull up the list of queries. I'll pull that up in a little bit. We can edit that. So if we go to GitLab here, and if I pull up any one of like, what was an example that I did? Um, um, Modules, maybe? No. Let me find one. App models. I'm trying to find one. What's a good example? You guys know of any in the monolith code base? I'm trying to think. Let's just do user, I guess. We could do user. What was the one that I pasted in the chat before? Do you remember? Um, it was like something with attributes or has permissions or something. Well, we can just go here. I'll just pull up any one of these. So let's do user. Let's find like where an actual. Okay, we could do this. Yeah, that should be it. What is the filtering ability again? I forgot the syntax. There it is. It's brackets. There we go. Cool. So this is just one definition, right? We go in. Now we've got the class to the method. So I just pulled out the method. This is the class. That class, of course, links to the file node here. This file has all these different definitions. And yeah, it's like pretty quick how fast it can query that number of nodes. I'm like very impressed. So yeah, we have all these definition nodes here that we can query. I had a bunch of like fancy Cypher queries, but I just lost them all because I deleted the container which had them. So um, I'll have to pull them up. I can pull them up while you guys have questions, I'm sure. But yeah, so this is all some of the definitions here. This is file node. We can go to any of these definitions, and then this is the directory. We can go back up, and it's just basically the graph database. So pretty cool. And then the next step is basically turning this into an LLM tool that can be queried, and then asking it questions about the code base, right? So, um, but it's at the scale of the monolith. Like this is like one of the biggest projects at GitLab, if not the biggest project. Not maybe of all of our customer stuff, but yeah. What do you guys think? It's kind of cool, right?
Yeah, this is great. I you said it took some 10 seconds, right?
9 seconds in this case, but probably I think in the real world, meaning that when we get this like production ready and out to people for the first like iteration and getting it out the door, it might be longer, right? So I would
Mhm.
say like 30 seconds or something, but not hopefully not more than a minute or 2 minutes for the monolith, that is. Like for other smaller code bases, it should be like within seconds or less, right? Um,
Yeah, that's perfect.
Yeah, this is great.
um,
Awesome.
so yeah, that's basically it. Um,
Could you maybe show an example of like a definition that contains another definition, like a class that contains a method?
yeah. Class to method here.
Okay, cool.
So this is user class here,
Hmm.
defined in app models user.rb. And we got the of course the I have I'm saving the byte range and the line number. We'll probably want to store both, like the byte range plus the line numbers, maybe feed the line numbers to the LLM or something. Uh,
Yeah.
Yeah,
uh,
usually what you can
And
do is just do a tuple with four elements. That's at least how it's represented in tree sitter. It's yeah, start line, start column, and
yep.
end line and column. Yeah.
maybe we don't need to store the file path, so we can just get the parent node from.
Mhm. I mean, we could do that, yeah. Um,
I don't know if like I don't know how big a deal storage constraints are. I haven't been keeping up with that conversation. Um,
Yeah,
so
yeah, it could be like extra storage. Or we could point it to a file node, like point it to the file node.
That
Um,
might be better. Although I guess all those edges, right? Be drawing quite a few of them if
yeah,
every single it might be better to do it in line. I think we should just experiment with that and
yeah, we'll
see.
figure all that out
It's
later.
so
Yeah,
hard to say
great.
without like actually using it for like multiple things. Like right now we have only your end-to-end integration, which is what it is in terms of like it's very basic in terms of usage.
yeah, yeah. It's very basic. But it's like a code path, and that's I guess the most important thing is we finally have like a code path, and then
Yeah,
Yeah,
now we can actually
now we can iterate.
yeah,
um, build off of it.
Yeah,
absolutely.
yeah,
Not
this is
even off
great.
of it. We probably want to break this up. It's quite monstrous, but I want to see if I can pull up. Give me a sec, guys. I'll pull up like some of the previous queries.
And
Um,
just like out of curiosity, while you do that, how much of the end-to-end stuff you wrote is language agnostic? Is it like fully language agnostic or is it kind of tied to Ruby?
um, I would say half and half. I really don't think we're gonna know until we do like 3 or 4
Yeah.
languages.
Yeah, I agree. I think once
Um,
we get 3 or 4 down, then we can figure out like abstractions and
Yeah.
because
Yeah.
import-based languages like JS, right? It's just a very like different resolution technique than say namespace languages, right? So I'm assuming
Yeah.
like the Ruby, I don't know how much like Java would or Kotlin would benefit, but I'm assuming like something like C# would benefit from similar patterns, right? Um,
Yeah,
I don't-
there are a couple of languages I think like you said, import-based languages probably be able to reuse the same logic for most of like Kotlin, Java, C Sharp, JavaScript, TypeScript, maybe even Python. Probably Python. Don't see why not.
for
um,
for the first phase of work, like just getting definitions out, I feel like that could all be language agnostic, right?
Yeah.
Should be.
Yeah.
Yeah.
should be, yeah.
Even for FQN construction, like I know that we're propagating a metadata down as we're kind of building the FQNs. If we just have a metadata field inside of like the FQN, that can just be an option. And you can set up a struct and propagate data through that instead of doing like a language specific FQN, a metadata struct, and then yeah, just reuse it.
Yeah, we'll need to talk about that for sure
Yeah.
because there's definitely a lot of room for opportunity. Um, I'm trying to get some queries for you guys so you can see. Okay, I got one. It just shows how cool it is. Like the different type of queries we can do and um, uh, like the type of data the LLM can get. So I'll just show you guys. Can you see my screen?
Mm-hmm.
Mm-hmm.
So like this one's like I think that you could actually like theoretically, but I think we can write full blown, static analysis type of queries. Like this one's pretty wild. Like this one's checking like inheritance stuff.
Mm.
Um, so it's like checking, does the parent class have the same, um, like basically querying the inheritance structure of different things. So like if you look this up in the actual code, it's quite neat. Um, I'm trying to find an example here, but like API integrations, right? The child method here, we have this parent method because it's like inheriting a class essentially. Because I'm defining a relationship class to class if like a class is defined within another one, or inheriting another one, sorry. So that one's pretty cool, and then this one's also really cool. Like um, this one's finding all definitions within like a controller, right? So this one you could like you could probably do with like a SQLite query, right? If you were storing in that. But then we could like follow this up with like, okay, now get all like calls for this definition, right?
Yep.
So it's like basic right now in the sense that like, this is stuff that a SQLite, engine can query, but it becomes really powerful then when we can actually, connect the edges and query the relationships. So I thought this was like pretty cool. And this is like Rails specific, right? And you can imagine if you're like a security engineer and you want to audit dependencies, etc., this is like a gold mine. So
Yeah.
yeah.
Cool.
But with that being said, definitely want to walk you guys through at least everything on the indexer side if you want. And I think that'll show at least some of the parser stuff that we want to talk about, right? But we can do the reverse way too. It's up to you guys, um, whatever you prefer.
I'm
Yeah,
fine
let's
with
just see it at a high level first, and then
Yeah, why don't we start with the indexer?
Okay,
'Cause I think we're all less familiar with the indexer compared to the parser.
sweet. So So I've kind of broke down the CLI. It's pretty basic. It just takes, you know, the inputs. It uses Gitalisk, right? So all the determining is this a Git repository and running Git operations is through Gitalisk, right? But then I've created a few things, and I have ideas on how we probably want to structure the indexer as far as code and just like making sure we have correct architecture and, you know, not clean code, but like proper dependency injection and whatnot. Because I think there's going to be different things that we're going to need throughout the different phases. But first, it starts with this repository struct. And so this has like pretty much all the execution functions for like performing everything, right? So it starts with index repository. And then I kind of broke this down for you guys before, at least Michael and John. But what we do is we first collect the files. So it uses GitList to like gather all the different files. And then we split up the files into, you know, a various amount of worker threads. Right now it's just using the CPU count. But you can also, so you can see that here, it's just using like a num CPUs Rust crate. But you can also we can like manually specify threads like in constrained environments, etc. Um, so what it does though is it spins up a few worker threads. It spins up a channel to like essentially for each worker thread, it's going to go through and perform the work, as in parsing the file and extracting the definition with the library, and then sends that data to the channel. And right now it's just all sitting in memory, which was like very interesting to me because the max amount of memory, like if I show you guys actually, um, give me 1 second. If I show you CLI here, so I'm querying on CLI, right? So I'll spin this up and then like quickly open it. Um, so let me go back and let me do target, let's log that, and I'll open this up so you guys can see. This is the memory usage. So it climbs up to like, and again, I'm storing all of the reference data, if you will. Climbs up to like 600 megs, and then when it finishes, it goes away, right? Um, but that's not as much data as I thought it would be, at least in like memory consumption. But what it does though is, at least now, it just takes all of the results. So you can see in here, indexing, where is it? I'll just go to the file to show you. So we go to file, this file results here. So it runs through the whole thing, right? And this is one of the things that if someone can write this down, this is like something we'll need a book, kind of like bookmark or pin. But like you said, Michael, we can probably, you know, abstract some of this away. But it runs it through the same algorithm. Like it reads the file into memory and then runs generates the parser for the particular language, loads up the rule manager, loads up the matches. Once it has the matches, it runs it through the analyzer for actually extracting the definitions. And I'm just saving the definitions directly here. We're gonna need to think about like how much again like the data structures are going to change between different languages, and if we should just store it like in one struct here, this file processing result, or should we store it in like a per language way. The reason why I say that is we might want to store it in a per language way because when we do framework analysis, like, you know, Next.js has conventions, Rails has conventions. I'm not sure about Python too much, but when we do that project level analysis, it might be useful to store it. But right now, like you can see, I'm pulling this definition info struct, and this is being imported directly from Ruby, the type. So like again, it's very hacky, right? It's not actually you know, building it for multiple languages. So we'll need to think through, okay, when we go and examine one file, A, does it need any context around it, right? Like what type of project this is, and B, how are we gonna take that end result and pass it upstream, right? Is it gonna be like language specific or gonna be universal?
Could we maybe do that like at the file node level, we have some sort of an additional column in conjunction with the language that specifies like the framework. So if it's like Python, Django, or
Yeah,
Ruby, it's Rails, instead of storing it on a per definition level. Although, I mean, that doesn't necessarily help with like, you know, the relationship between definitions. I mean, it might not be as big of a deal as we think, because
Mhm.
we're seeing this, from the perspective of actually putting context into the LLM. Like,
yeah,
they'll have pretty good understanding of like sort of the nuances between frameworks.
yeah.
Not sure how much of that we need to encode right away. But
No, I'm not saying encoding in the database. I mean for our own and for the analysis phase. So
I
this
see. Okay.
file processing result here, just like I was kind of showing in the design indexer. So if I show you guys again, uh, where is it? All the way down here. Yep. So I'm talking about where is it? Pre-work. I'm talking about here. So when we get to, so like we're parsing we parse the files, right? This chart is actually a little bit inaccurate because we should have an analysis service. This should be called analysis service. So I'll update that. But you can see like we're splitting up the different threads. We're parsing the results. Like, do we want to make the results language specific is the question, right? I don't know.
Yeah, could you pull up the definition info struct just so we could all kind of
Yeah.
take a look at it? That'd be good.
Yeah.
Okay.
And this is not the FQN. This is just the definition. The FQN is encoded in the definition info struct.
Right.
So I don't know if you guys, I know we talked about a little bit on the merge request. Do we want a unified definition info struct or no? John, I think you're on mute.
Oh, I don't see any reason why not. I can't imagine these fields will change across languages.
Okay.
The type of the FQN will, but that's it. We can template that.
So you're saying like, we could do something like definition info, generic here,
Yeah,
FQN type,
Yep.
something.
yeah.
Yeah, just language type.
Yeah, all this is like, not that important right now, but it would be nice, I think, once we get more people working on the parser in parallel to have like
Yeah.
less code duplication, more of a unified like interface.
Yeah, we'll just be able to
Analyzers
close them ours.
implemented.
Yeah.
Okay. Is that what you wanted to see though, Michael? Or
Yeah. I just want to take a look at it because yeah, I rebased on your code, but I'm not sure if it changed since then. So I just wanted to take a look at it. Yeah.
it hasn't changed much. I just added this so that the definition types.
Oh, right.
You did make a good point. We probably want to think about maybe later on unifying this between languages, right?
Yeah, but for now we can just copy it over and as you
Yeah.
say, yeah, like avoid premature optimization. Once we have all of our parsers in, I think it's worth just like an abstraction run at that point. But at this point,
Like
yeah,
a quick
it's
half-day refactor.
I think that'd be good. Like, let's say we get 4 or 5 languages deep, like all the ones we are currently working on right now. I think we can like take a step back and say, okay, how can we generalize this?
yeah, because then we'll know like the difference between the namespace languages and the ones that are like sort of like file-based imports like we talked about, like Python
Yeah.
and JavaScript and
Okay.
yeah. I guess for definition info, when you're actually writing definitions out to Parquet, I'm assuming we're not keeping things like the environment variables that we're capturing from like AST grep, right? Or match
No,
info.
no.
Oh, okay, cool.
But that's what I was saying. It was very interesting because I was like, should we discard the data? I was just like, I was moving fast, so I didn't really think much of it. That's why I thought it was interesting because the definition info. So if you look at the struct, it's including the Ruby FQN here, and it's including the match info and does match info capture it? Yeah, it captures the environment map. Like it's theoretically keeping the AST grep encoded information like in memory. Let me see if Ruby FQN does that as well. I forgot. Ruby FQN metadata. No, this isn't really keeping that. But I'm pretty sure the captured environment, I mean not the vars. I might not be capturing it. I have to see. I don't remember whether I was capturing it or not. But yeah, like you said, like we need to determine whether we should like pass upstream on the Rust side, right? Like for Golang and other languages that want to bind to this library, like it doesn't make sense. But for Rust, like maybe it makes sense to pass upstream like the actual tree, right, in memory. I'm not sure. But at least like what it does right now is it gets the file result back. So or is it, if I just search result, where do I save it? I forgot. File results. Here it is, file result. Here it is. So like what I'm doing here is I'm just collecting. So it runs it through index repository, spins up the worker threads, process them each on a separate thread, and then sends the results back to the channel here. And then once it collects it into the channel, it just stores it to like an in-memory, literally just like an in-memory collection. And that's why I thought it was like kind of interesting because the monolith is pretty big and it did pretty well for memory. We probably don't want it to be like 600 megabytes of memory, even if it's like 10 seconds.
Yeah, if we're writing to Parquet, we can probably do like buffered writes or something like that, and just have like a
Yeah.
It would be based on like the row groups, so we can write, yeah, if there's like n threads, we can write maybe n row groups and just keep them smaller. It'll just keep us with, it's like impossible to predict the exact amount of memory that's going to be written, but you can clamp it down to like,
Yeah.
okay, like 100 megabytes per batch. That should be fine, right?
Yeah.
Okay.
Yeah. And again, we're talking about monolith scale here. So
Yeah.
for like GitLab language server or like JetBrains, it's gonna be like 10 megabytes of memory.
Right, yeah.
Right?
Yeah. Yeah, we can have like a max yeah, that we specify when it actually needs to be buffered. So
Yeah.
yeah.
But yeah, so that's how this part works. So once we've collected it, I run it through the analysis phase. So where is that? So we got the analyze and write graph data. So it runs it through this analysis service. So the analysis service takes all the parsed results and then like literally just defines the relationships programmatically, right? So this is kind of like the transform part of the ETL process. And so like this file system analyzer creates like all the directories and parent-child relationships for the directories and files themselves. And then in Ruby, it takes each individual file result. It does some tracking through like what it's visited. Ruby has that kind of one quirk where modules like you would want to theoretically save a definition for like you would theoretically want something like uh my file, like your initial thought would be like, okay, let's save the definition of my file just like this, right? This isn't really correct, at least in my opinion, because like this is all technically one definition I mean, my module is, right? It just has multiple locations. So this was that one, counter, like not the one quirk that I was talking about in Rubyland that I'm doing for at least for module definitions and just module definitions, I believe, where I'm like actually checking, A, has it been visited before? If it does, just append like the location. Um, um, if not, like like actually just merge it basically. So, and that's how I ended up with a structure in the graph database that actually works. So if we go to user, just like this, right? The user class, um, nah, actually user is not good because that's not a module. So let me find, I think it's like definition type question mark. Yeah, definition type is module. Yeah, okay, great. So these are all the modules. Like this isn't a module here, right? But this is technically, it should be writing multiple locations. I'm not sure why it's not. Um, but if like the module spans multiple files, right? You want to like capture that in the actual metadata. I don't think we want to create separate nodes. Maybe we do. I don't know. But I figured like it doesn't really make sense for if you have a module that you define and classes that you define under it and those classes span multiple files, does it make sense to do that? I'm not sure.
Probably
For
best to minimize the amount of nodes and just have richer metadata.
I don't
Yeah.
know Ruby, so what do you mean by spans multiple files? Like imported in other files?
Yeah, like I'll show you in like the monolith.
It can only be defined in one file, right?
Um I don't think so. Um let me find a module. Again, I'm not a Ruby expert, but based on what I've seen, um EE types. Let's try that. Actually, that's not going to be hard. That's also why this is so useful, this graph database, because like once we get it like in a decent state, we can actually query things like easier.
Hmm.
And I would much rather use this than regular code search for like big Ruby code bases. Um, custom complexity schema. Um, I don't know where we would have a module with like multiple. Actually, a Banzai I think is a good one. Let's do that. Cool. All right, so like this is one module here, and then you can see all the different file nodes it points to, and then all the different definitions that are under it. Um,
So yeah, I get that like a module can be shared across files,
yeah.
but can a class definition can a class be defined in multiple
Multiple
files?
times. I'm not sure. Yeah, I'm not sure. I don't think it can be.
In C
Unless
sharp,
you like
yes.
inherit the class or something and then extend it or something. I
Yeah,
think.
that'll be defining a new class.
Yeah. You were saying yes? Oh, then what about C sharp? Is that the
In
case?
C sharp, yes. C sharp is very crazy.
You
How does
can
that
define a class in multiple
how does that
files.
work?
The same class.
Partial classes.
Mm.
Okay.
So
Oh,
a lot of legacy code bases gonna have like one large class, but they're gonna be split like in 20 files.
That's
So
crazy.
approach parsing each file separately will not work for C sharp, like completely.
Wonderful.
see, this is why I'm glad we're doing C sharp because
Well,
like yeah.
Yeah, like you are talking right now about all different stuff, and I'm sitting like, oh my God, all of this stuff not gonna work with C sharp because it's super.
You think there's no way we can just parse each file one by one for C sharp,
Uh,
do the resolution afterwards?
yeah. So for example, partial classes is the first case. Another case, you can have different. You can have same class name, but in different namespaces, right?
Mm.
And you can have like all of them imported, and you cannot statically, like only from one file, you cannot statically guess from where it was taken, because a lot of code just tells like var some variable equals to some result. And if you look only at one file statically, you cannot figure out from where it comes from. You need first to build like the whole tree of files and then like one by one resolve them.
Well, I figure like if you have two classes with the same names but in different namespaces, they'll have different FQNs, right?
Yes, but you need to, like right now we try to build it each file separately, right?
Yeah.
So you want to know beforehand
But to know the name
which
to resolve the FQN.
what you use, like which object you use, because you call some methods and you want to know from where that method comes from, right?
For Python, for example, like, of course, to like resolve references to imported functions, you need to look at more than just one file. But at least my plan is to like, um, trace within a single file, trace the reference back to the import statement, and then in the indexer, um, like figure out, use the import statement and all the other import statements and all the other files to figure out the original location of the function that's being referenced and like do the resolution of that layer.
Yeah, in
Need
C
to have the
sharp,
parser.
I know that in Java, for example, you import the classes themselves or different objects, like different stuff. But in C sharp, you import the namespace,
Hmm.
the whole namespace,
Yeah, that's weird.
with
So it's
all
like C++.
classes.
Yeah.
Yeah, with all like classes coming from them. So if you have like two imports with conflicting objects, you don't know beforehand where it's going to be resolved until you build like the whole tree.
So the
And
first, so the real amount of work is going to be on the analysis side for C sharp, essentially.
Yeah, for C sharp, like you cannot just fit each file separately. You need
yeah,
to
that
go
kind
like
of
from top.
challenges the whole fundamental design of our parser, right?
Yeah.
Okay.
Yeah, I can show like
Figure that
the
out
quick
later.
example for you if you want, like right now,
Sure.
if you
Yeah.
want. Uh, let's do it. Uh,
But does it actually challenge it?
I
Because
don't think it
you
challenges
can
the
par you
design
can
of.
parse file by file, and then you have the another ETL step that
Yeah,
takes
I'm
the
just
whole
saying.
thing and then
Yeah, C sharp is going to have like more of a bespoke, probably
Okay. So we'll have
analysis phase.
so we'll have like for some languages an option to like parse multiple files at once.
Yeah, I mean, it's all parsing in parallel. And right now, what I was saying that was interesting is it doesn't use too much memory during the analysis phase on the scale of the monolith. So, in the analysis phase, we could also like write to disk when that happens to save on memory. But I think for C sharp, you have to probably load everything into memory to do some type of like analysis resolution for it.
In the parser, right? Not the indexer.
No, in the indexer.
Oh, okay. Yeah, I think for like almost every language, you have to load it all into memory
Yeah,
yeah.
yeah.
in the indexer to do
Yeah, as
resolution.
long when we start doing like resolving stuff using imports or whatever, like we're going to know the whole thing. Going to
Okay,
need to
yeah.
have the whole thing loaded either
Yeah,
way.
yeah. That makes perfect sense. Sorry, I thought you were saying that in the parser, we're gonna have to load in multiple files to do an
No, no, I don't think so. Because then that would be scope creeping the parser.
Mhm. Okay, in that case, we're good.
and one more here. User. So they're in different namespaces, right?
Okay.
They'll just have different FQNs, right?
Yeah, it'll
Yeah, they
say
should
that
have-
it's
Yeah,
namespace.
but if we use them in program now, you need
Does
to know beforehand, right?
does C# let you have conflicting like imports? Like in Java you can't have conflicting like if you import two packages that have the same class name, you'll have to specify which one you're using. Is that like a thing in C# or do you not care?
You can have conflicting ones, but then you have to explicitly specify which one you want to use. Like if you have
Mhm.
yeah, you can have both
But
of
then
them.
there you'll be able to with the imports, then you should be able to figure out which one it is,
Yeah.
right?
Like
As long as you
get-
capture those, yeah, from the file.
yeah,
So yeah,
but it's
here
very similar to Python too. I mean, it's the same.
so
same approach.
because we have a conflict, we have to do this one.
Okay.
We have to explicitly say it, but for example, yeah, but statically, you cannot figure out from where it comes from, right?
Wait, why not? Because
More
Yeah.
you can now.
Comes from that. You'll figure out which namespace it comes from. So in the parser, we'll like get the FQN for the reference, which would be like console app3.namespace2.user. And then in the indexer, we'll find the original location for that FQN. Like we'll look at all the other files, look at all the other definitions in those files, and find one that matches.
Yeah, I need to come up with some better examples then.
yeah,
How
that's
to do
like it'll
this?
work.
I think it's like once we have the project tree of like all the FQNs, then we'll be able to go back up and
Match the FQNs, yeah.
Yeah.
So like if you're
Yeah.
referencing something that's imported, that's not defined in the same file, but imported from another file, the parser will compute an FQN for that reference, but that FQN will just be like the imported name, right?
Hmm.
Be the true location of the definition. We'll resolve that in the indexer after we
Yeah.
parse all the files.
one question I have, and Joe, I'm not sure if like that's something that we had to consider for Ruby, but do we probably want to keep some data about like method visibility, so like whether they're public or private, right? Because I feel like at some point we feel like that's relevant information for definitions.
Uh,
Unless I mean I'm not sure if that's something that's like language specific. I feel like every language has
Is it
their own
important for resolving references at all?
I don't know for references, but I feel like for definitions.
Yeah, or like you in the tool, right? Like if you expose the LLM tool, it could be, um, you can filter by private or public.
I see, yeah. There's a ton of
How,
attributes then that we should think about capturing if we want to go down that path.
it might
Like
be
if you have multiple
It
functions.
might not be, it might not be like useful. I don't know.
well, that's the one that's it. So that's definitely something we can like since we know we can just drop the DB and reindex everything. That's the decision we can definitely take later.
Yep.
Yeah.
But I have a question. It might be like a stupid question, but how do we plan on the DB? Like how do we plan the DB is going to be queried? Is it like are we going to create a tool that given like a bunch of FNQs from a file is going to try to resolve like is there what like is it going to be like for just chatting with the code base? Or are we going to use it for code generation? Or yes to all of those questions?
I can show you.
Because I guess the thing I'm trying to figure out is like, yeah, we're going to be parsing these files and writing these analyzer and indexers, but like for I guess like the end goal
Yeah,
is
I
kind
can
of relevant.
I can show you. At least on the what I did for the research agent, and then I think Michael and John also have like ideas.
Yeah, I'd be down because that's what I mean. Because now I know we're doing this analysis and all of that stuff, but without exactly knowing how we plan to use it, feel like
So
I'm missing something.
from what
Is
I understand, just through talking to Tim, um, there's this sort of unlocks a billion different use cases. One basic one is chat with your code base. Like we give our agent a tool that can like get the definition or the reference or references to a definition and bring that into context for generating an answer. But I imagine it can be used for any AI application that requires like code base RAG. So like code generation, for example. Um, I think there's also talks of using it for non-RAG applications like security, like taint analysis, for example.
Mhm.
But I don't know much about all that.
I'm syncing with Mayor from Oxeye next week. So um and I think he has ideas
Cool.
on how it can be used.
Uh, I can show you on the real code base, probably.
Okay.
I don't
Yeah,
know.
sure.
So yeah, for example, it's the actual Visual Studio extensions that we have. Uh, so we have, for example, language server client provider. Where we use it. So we get a client from it, and we call some method on it, and we get some result. So when we start to parse, we will get, for example, this method. And now we need to find its definition, right?
Yeah.
Where are we going to look for its definition? We will like backtrack. We'll go
Yep.
to
Well,
last client,
like
just provider.
the analyzer, the parser will like
Yeah, that's in the scope of the parser. So anything that's single file, the
Mhm.
parser will do. Anything that's multi-file, the indexer will do.
Yep, exactly. Yeah, for this file,
So
like, we'd have to
we
do
will
some
know
data
that
flow
this comes
backtrack.
from here,
Hmm.
and it will be a different file, right?
Mhm.
But how do we know which file, from which file this comes from?
So in this case, the FQN, you would have to save some metadata, right? For like trace back where this is comes from, right? So
Yeah,
let's
so
say you
this
have this
gonna be
file,
the top level, right?
right?
Oops.
So then, okay, so I'm not a C# expert, but click into that LS client provider.
Yeah, it's different file, right?
Yep, I click it. So this is defined where,
Under this namespace, which is incorrect, but okay.
okay, but namespace, GitLab extension, language server, public interface, LS client provider, right?
Yeah.
So this would be a definition, an interface definition, probably is the signature, right? Um, and then what you would do is when you parse both of these files in the indexer, you say go back, you'll probably have like marked different places in this file that need a resolution.
Oh, okay. So we figure out that we uh, that we use this namespace. So we use this namespace, right?
Yes,
Yeah.
So because we use it, all stuff should come from like any of this.
yes. And then you
Uh,
traverse over all the available definitions and find the one that matches, essentially.
because the challenge for me was that sometimes it happens that there might be like three places where same class is defined by different namespaces. I don't know, for example, uh,
No, it's the
for
same thing
example,
for Ruby. That's
database object and
yeah,
front-end object, like data transport object and database object, right? They have like same name, but they're like in different modules. One which talks with database, one
So
which talks with client.
if you're using both of those namespaces though, the same file, and then reference that object, when you have to like explicit,
In that case, we'll have to specify it explicitly,
I think
like
it'd
I
yeah.
be
showed
okay
before.
then when it
And then
comes.
that's
Yeah.
what the Roslyn compiler is doing under the hood, right?
So it will be a job of analyzer to link everything together.
Yes.
Okay.
Does that make sense?
And
Yeah, it makes
A bit
sense.
more?
and thinking out loud, it's even something we need to consider with Java and Ruby. With like, we probably need to have packages and namespaces or whatever they're called as their own like top level node, and then on which like contains class definitions, and then like build a tree like that so that when we get to the reference,
That's what I'm doing with Ruby for sure.
yeah, you're starting like exactly. So you have like the module, and then you drill down until So we probably need to do something like that. For definitions, so that what we're talking about is like when we get to the reference of the method that's called, we can trace back from the reference to the definition.
Quick question. In C sharp, you said you mentioned oh, it looks like you're typing it now. Yeah, partial classes. If I have two
Crazy.
files with like
Wait, so what is technically the first definition of the partial class?
yeah, that's what I'm gonna ask. Is there a root definition
Uh,
class?
there is no root definition.
Okay,
They're
so
gonna be linked.
that's kind of a problem then because you
But if
can't
they
No,
share
no,
the
no, no, no.
same
You can
name,
No,
just
I don't think it is. I
you
don't
treat
think
it the same way as
Analyzer
module.
gonna merge them, right?
I don't
Yeah,
think you
so
need to merge them.
no. The analyzer should, well, I don't know. This is what I would do is I would treat this just like a module. Um, the true definition is just one user node linked to two different locations, like an array of locations. And then when the analyzer, like Bogdan said, will know that, hey, this is a signature, this is a partial class. This is what I'm saying. Like, this is probably C# specific. It'll come across the node and say, oh, we found a partial class that came back from the parser, a definition of a partial class. Now let's go search all the other partial classes and link it.
But let's say like let's say you have the same class name, two different files, like two partial classes. That makes sense what you're saying. But what happens when another file instantiates that class, references it? Which um which node do we point to?
That's what I'm saying. You merge both of these. You treat it as one definition node
One
with
node, even though it spans
location.
multiple files.
In the metadata, the location is the multiple
Got it.
locations are shown, and then you point both or that usage to just that node. Does that
Yeah.
make sense?
Gotcha. Okay, that makes sense.
This is why. Oh, sorry.
Go ahead.
Yeah, this is what Angel was talking about. One module spans across a couple of files, right? Same gonna be applicable here.
So that's interesting because we're thinking about having like the location attribute like as part of the main structure. So maybe like in some languages, we are going to have multiple locations instead of only one in the code base.
Yeah,
Like,
but that's what I wanted to when we were talking about that in the parser comments in the MR. I was like, we should probably just sync because we'll be able to talk about this a lot easier.
Yeah. That's a good point. So now like we can't just have one location field in the definition because some definitions have multiple locations.
What about the
No, I think
overloads?
we can say the location because you can only, unless you can have multiple definitions in the same file for the same thing. I think it's okay to say the location. It's just on the indexer side we cannot have. It should just be
you're right. Like on the parser, there's
either always an array.
Yeah, you're right. On the parser,
Or
there's still going to be one location, but then when you
That makes
index
sense.
the whole thing and create the nodes, then you may have multiple locations. Yeah.
yeah, and
you're
so
right.
if you want a generic data structure, it would be locations as an array, or it as always an array, or it'd be like language specific. Like we would create a property for location if it's truly only one location, like JavaScript, right?
Yeah. I think like what might be smart for now for cases like this, let's not try to make a language agnostic data structure. Let's like pump out a few languages first, and then
That's why I kept saying that. But
notice patterns.
I'm sure Michael is probably. I bet you we're gonna write it all. We're gonna push it through, and then Michael's gonna be like, guys, I know how to do this across every language.
Yeah, I think, which would be good.
Which
I
would be
think
great.
Yeah.
so
Yeah, we should wait. Yeah, premature
if it-
optimization is bad for sure.
Yeah, I know this feeling. If we start right now trying to generalize everything, we're just gonna waste our time, to be honest.
yeah. And
Yeah.
what about Lisp, guys? You know,
Oh.
I love Lisp.
I'm not doing
Closure.
this.
Love
Oh,
Lisp.
camel.
I wanted to touch another thing that I don't know if we discussed. What about methods with same names but different signatures? How we define them? Do we just have like a name and
the location
type of?
is going to be used to disambiguate that. Like you're talking
Oh.
about the FQN. Like how do we handle that case?
Yeah, what's gonna be FQN?
Wait,
Like, is it
process
going
data. What is the difference between these two? Process data. Wait,
As a
you
parameter,
you have two
different
methods with
parameter
the
and
same
return
name.
types.
Well,
Yes.
this is like constructor overloading, right? Unless I'm. Oh no, these are methods. Never mind.
Wait,
Yeah.
hold up, go up. So you're saying you can have 3 different methods that are the same name
Yes.
that I don't understand how you would call this.
It was just
It-
like C++.
It's like that example,
I'm
Mike.
surprised you can't do that in Rust.
They are all callable, and the same goes for Java.
Yeah, to disambiguate these, I think
I
we
feel like
discussed
that's
using
pretty
location.
standard.
Oh, so
Overloading is pretty
calls a different
standard.
method depending on the object type passed into it.
Yes.
Yeah.
Gotcha.
or the return type.
Yep.
So the part of so you just make the signature go up. Like when you parse this file, you make sure that you have the signature as part of the FQN.
Yeah, inside of the FQN like part, the
Yeah.
type, it would either be an argument type or a return type, and that
Yeah.
would
Yeah, I for C# I would put something like string,
Yeah.
then like process data, and then like int. Here
Yeah.
is gonna be like double process data in string without these names, but it
Yeah.
will have in string.
So I thought we settled on using location instead.
we can also do location.
I
It's-
here
Location too, but
I linked to I just sent a link in the chat. This is like my proposal, for like sort of the 2 options for handling this case. One would be using the full signature as an FQM part, and the other would be like using location.
what are the downsides of both?
I think location is just easier to do. Like you mentioned that thread, Angelo, like doing the full signature would be a little bit more AST work, nothing
Yeah,
crazy.
you're right. You're
And
right.
then
It's
one
gonna
other
be-
downside of using the full signature is like we're gonna be giving these FQNs to the LLM at some point, right? The
Yeah.
longer and more complicated they are, the worse it is for the model. Keep track of what's what.
Yeah.
Yeah, and also these types can be complex, right? They can also come from different files.
Yeah.
So it's
Yeah.
gonna be like signature linked to
I
something
think
else.
eventually we'll want to be able, like for security analysis, like that's part of what taint analysis, it actually inspects the arguments.
Mhm.
That's later down the road. So I think location based makes sense, but eventually we might want to like think about.
Yeah, maybe as metadata, like the language specific metadata, this is something we'll eventually include.
Yeah.
Like the full signature. But I think for now, just to disambiguate those methods with the same name, location is good enough.
Okay. Okay.
It-
That works.
Oh
for
my,
me.
it's going to be difficult, right?
I'm telling you
Statically
guys,
figure
this
out even the location.
This is like actually compiler work. This is what
Yeah.
Yeah.
compilers do.
That's why
Yeah, we're
there
going
is
to-
no universal call graph generator that
Yeah.
you can find online. It's hard.
But
You can
that's
hack
why
it
this
up.
project is special in my opinion, because like now when we roll this out, people can just spin up any project and get a call graph, right?
Yeah.
Like that's
Yeah.
And nice
that's
and
exactly where the
fast.
value is. And then we connect that to Git and traverse Git, and then we connect Git to the remote, and then the remote connects to MRs, and the MRs connect to issues, and those connect to epics. Now you have the entire
big, beautiful graph.
Big,
That's
beautiful.
right.
Now I see that Python, Ruby, JavaScript are the easiest ones because a lot of stuff is dropped there because a lot of stuff is dynamic. But for like C# or Java, it's going to be difficult. A lot of logic is done by compiler,
It's gonna be
and
difficult in
especially
different ways. I think like for the dynamic languages, resolving references is complicated.
Yes.
That you really have to do a lot. You have to do type inference. You have to track data flow.
yeah, but a lot of that stuff is done in runtime.
Yes,
We're never
exactly.
going
There's
to
a
be
lot
as
of
good as,
runtime ambiguity that we'll need to think
yeah,
about,
we're
either
not
ignore
gonna
or
be good.
handle.
Yeah. I don't
We
think we'll
But
be
need
as
to
it,
we need
but
to
we can
kind of
get,
draw the line. Uh, I was just gonna say like we kind of need to draw the line that like hey, this is a parser, like this takes a single file, parses it, and then we do our best, because at some point we don't want to
Yeah,
build our own like compiler for each language.
Yeah,
yeah.
And then like then
I-
that's where we messed up, like because we could have just used the one that's already out there.
Mike Angelo and I have like discussed this a lot, at least for like Python, JavaScript. There's so many edge cases of like runtime ambiguities or naming ambiguities.
Yeah.
We can't handle them all. I think what's best is like for the first iteration, do kind of the minimum you need to get like 80% coverage, roughly speaking, of like most cases, and then write down the cases we aren't handling so that
yeah.
we can fix them later in the future. It's
That's
like
what I
added
added
to your issue.
I added a coverage file in the Ruby MR. I think we should do that per language.
Yeah,
What is
yeah.
yeah,
Yeah.
that's
Well,
perfect. And then it's especially important because the initial use case of this is going to be in RAG. And, from the perspective of further developing the parser, handling additional edge cases, all that stuff, we should just look at the evals and be like, oh, covers 90% of cases. Do we really need to do this extra work? Probably not, right?
yeah, if we have
So,
good RAG evals, then that can guide our decision.
then-
yeah,
And as long as we architect it in kind of a way that can be extended down the line, I think
Yep.
that would be important, right? So then security people, if they need to do taint analysis through it, they can come and
right.
right.
Yeah, that'll definitely be, yeah. Once we get those 4 or 5 parsers done, then we can probably, yeah, just resync and probably pull in people from other teams just to be like, hey, like this is kind of the flow that we need to make it extensible, and then we can probably,
Yeah.
be perfect. Cool.
But yeah, I think for all these languages, let's just make a list of language specific edge cases.
Yeah,
Yeah.
that's
Yeah.
it'll be a book.
It'll be hard to draw a line that applies for all languages, It's
Yeah.
not.
Yeah.
I have another small question. In some languages, there is possibility to add documentation to the code, like structured documentation.
Yeah.
Do we want to like include that into ranges, or do we want to drop that?
If it's
Not yet, but I think we should do that later.
Yeah, I think if it's included in the body of a definition, it'll obviously be in the range, but besides that, yeah, we shouldn't handle it.
What about
If anything,
decorators?
it would be in the parser, you would parse it as a comment, and then we could have an extra metadata. Like we'd have definitions as a struct, we'd have references as a struct, comments as a struct, and the comment struct has look if it's linked to a definition, you specify the definition that it's linked to. Does
It'd
that
be
make
hard to tell if it's linked to a definition.
You have to parse a comment.
Like just because it's above a definition doesn't mean it's linked to it,
Well, you could
Yeah.
do you could do different phases too, like you know, one like if it's right above it, then it's might be like a candidate, right?
Yeah. We can worry about all this later.
Yeah.
Yeah.
One question I do have, decorators, same question. Like if a method is decorated, do we want to include the decorator in the range?
Oh yeah, that one's a hard one. I don't know.
I
I'm
suppose
gonna
we
go ahead and
should.
think,
I think we should include it in the range. Not sure about like the FNQ, but I think we should include it in the range if possible.
Is it a separate?
it's not really.
It'd be a separate node, yeah.
Is it a
Yeah, it's
separate
not-
node?
It's not really a. I don't think it'd be a separate node. It's not really a definition though. It's not like part of the definition.
Oh, so you'd say like you the you'd
It-
have some sort of link between the definition and the annotation.
Well, I don't know.
I mean,
think
it'd be
like,
referenced by it technically, right? Because the function that's being decorated is being called by the decorator.
yeah, it's a reference, exactly. It's
Yeah.
technically a reference. Like when a decorator function is called, the decorator function
Mm.
gets referenced first, which then returns the decorated function, which then gets called. So I think we should treat it as a reference. But
Yeah.
back to a point that I've made a while ago of like currently we're only treating function calls as references, but we should treat all instances of a function name as references, including a decorator. Um, but that's something we can do down the line. It's added to our phases of work. It could be in a later phase.
But not all, like I think in JS and TypeScript, it's a method that is called like before the method. But I think like in Java land or not in C# how that works, but you could just have an annotation to be some sort of like metadata holder. So like let's say you could define an endpoint by just saying whatever, like post this URL path,
Yeah.
this URL, and then at boot, like when the application starts, it just looks up at the method annotated with the annotation and extracts the value. And then so it's never really like something that's called like not in the decorator pattern. It's more like a just metadata.
Okay, so it's not the decorator itself isn't a function. It's not a
Yeah,
high.
like in Java, it's not. I don't think like it's really a function. Maybe Bogdan can correct me here, but I've most only seen it used as like kind of metadata.
And that if it's just
Hmm.
metadata and that's its own construct somehow in the language, it's not a function, then
It's
maybe
like define, yeah, it has its own, but it's like it's defined. Like so in Kotlin, you define like a public annotation, and you say like this annotation has a path or has a value or something.
So that'd be part of the FQN then, probably, right?
Yeah, thinking about it, yeah, probably.
Okay.
yeah, and that probably should be included in the range too, I feel. I because it's not a function call. It's
Could be
not
in the metadata for now, and then we,
yeah. Yeah, let me
and then
just put
we.
that in the metadata.
But yeah, I think I'll have to include like I said, you put it in a later phase, so I probably ignore them for now. But like I'll definitely make sure like I keep some track of that.
Yeah, I think for all these like decisions we make in general, we just got to write them down because there's a billion of them,
Yeah.
like so
Yeah,
many
we're going
edge
it
cases.
and like each for each language we're going to make so many decisions. Like
So
we
I
need to track
think,
them.
what do you guys think about, like you said, what about, it might be a little bit messy, but instead of the 1,000 issues that we have right now, we'll just close out, like, maybe, I don't know, not close out the issues, but find like one document and just put it all in one document.
I think at least for I made like an epic for my work, the Python parser.
Yeah.
And I
Same
suggested
for
like
JavaScript.
we just list it there, like in the epic. All the
I'm saying once we close out the epic though, we like
oh, I see.
work is put it in a markdown document in the code base.
That's a good
That's
idea, yeah.
that's fine too.
Yeah.
I think they'll eventually turn into issues if we want to handle them, but I think
Yeah.
it's fine for now. Whatever's easiest for people.
Yeah, I don't know. I'm just an idea.
I think probably for persistence, because like issues, I mean, I suppose just like, yeah, just opening a ton of them might,
It just clutters things.
yeah, it'll
I
clog
think
things
that's
up.
fine.
Yeah.
Or like one issue, open one issue per language that has a giant list. Uh,
It's just like a backlog. Yeah.
yeah, exactly. And then we can pick and choose from there later on which cases we want to handle, then those will turn into their own issues that have MRs associated with them. But
Yeah.
yeah, I think
So
for now, as long as there's a list somewhere.
Yeah.
Right. Yeah.
so as far as the MRs, so we like the definition node being a generic node. Should I make that as part of the Ruby MR, or do you want to do that in a follow-up?
I think so.
Okay.
What do you think, Mike?
I think it's probably fine considering it'll be shared by at least the import-based languages and well, I guess Ruby as well. So worst case, we can always like backtrack and
Okay.
fix it up.
Yeah. I think that's fine as well.
We can make
Yeah.
that shared. And we want the location as part of it, right? Do we
Mhm.
want to keep the metadata generic or do we not want to?
Let's keep it
The code's
generic.
still-
Let's just keep it as like an option. Because like that just opens a door for, yeah, it's like you can store anything that you want in there, and then we can probably figure out how to like generalize that later. I think that's fine.
Okay.
I have a
Um,
few other questions, Angelo, if you
Yep. Yeah.
about the Ruby work. I saw that you're capturing constants and treating
Yes.
those as definitions.
Um,
Can you just explain that? I just want to clarify like what is a definition? Because my understanding was that it was just a function or a class or module.
well, I'm capturing it primarily for like if you're referencing a constant, like at least based on what I've seen on like the GitLab code base. So like actually if we go to the parser, we go to fixtures. Like some of these are good examples. This would be labeled as a constant, but this is actually a definition, right? To a degree, like you're declaring a property on a class. I don't know if we want to declare properties as definitions, right? But
Maybe
I hedge
Ruby will
that
have
we probably
class.
do, but I don't know.
maybe I mean if we can like so to speak like prove that they're only used in a single file, then from the perspective of a RAG, like let's say we do a query that gets this class and we just inline the entire class into the context window, like all the relationships there will be implicitly captured.
Yeah,
And then the LLM will just be able to figure out. So
yeah.
I
Yes.
mean, yeah. So it doesn't.
Do you think, okay, that's a good distinction then. It might be useful to capture it as a definition, but if it's not found as like a cross-file definition, we should discard it, is what you're saying?
Probably, yeah, because we probably don't want to get too granular with what we're feeding like the LLM because there'll always be like they'll probably like I think it's a good assumption to make that for any like decently large code base, like on a per file basis, there will already be like a significant amount of hierarchy that's encoded, and that just means that like again, on a per file basis, whatever goes into the LLM will probably already have all of those things, the constants that are just used inside of that specific file, that sort of thing. But yeah, if they're shared across files, like uh, like in Linux, there's it's a concept called magic numbers, right? They're everywhere, right?
Yeah.
Like that sort of thing, or just like you know reading from environment variables and using those around a code base. That might make sense to capture, but I don't know if we should maybe do
Like
it as like a V1 thing.
like even JavaScript though, like my expertise, unfortunately. Like you could have export const, my const, right?
Yeah.
And this is used um
Mhm.
my const. My
But well, like out of curiosity, is that not like I think is that
actually
something
sorry.
that we should still capture as part of the parser and then discard as part of the indexing process?
That's more of what I'm getting at. Like these are not constants are not callable. And I figured what's being put in the graph.
No, I'm
Callable.
again like I was just moving fast, so we can not put it in the graph. That's totally fine.
I guess there's no harm in like extracting the parser because we don't
But from the
import the
parser
graph.
perspective, that's what I was saying. Like from a parser's perspective, it probably makes sense to extract it.
Yeah, I would expect them because like some of them are going to be called across the code base or whatever.
Yeah.
So like I guess even like private methods in the class, like if it's not or yeah, if something's not called or referenced anywhere, we could probably discard it at the analysis stage or indexing stage or whatever. But I think like when we parse a file, we should actually parse it,
Only thing
get as
that
much as we can.
only thing that worries me a bit, maybe it's not a valid worry, but like
Do you think it'd be better to relabel it as instead of a definition as a constant?
yeah, I just think like when we resolve references, the question to me is like, are we going to try to resolve references to constants? If we are, that's more work now. Like we're expanding the scope of the knowledge graph work, and I don't know.
Yeah, that's a good
I
point.
don't know if that's worth doing.
It might be worth it though in
Capturing them and like
JavaScript. In
putting them.
JavaScript, it would definitely be worth it because that's a good
Could be a,
20.
could be a function.
Yeah, it's like 20% of what people will write.
I mean, when I say constants, I mean, sorry, I mean non-callables. Like if a const x equals function, that's we have to capture that, of course.
Yeah.
All references. I mean non-callables. So like
I think that's what I'm doing in the Ruby
and
parser. Maybe I'm not. Let me double check.
I guess that was if you are, then disregard what I'm saying here.
Yeah, I'm not saying like capture a const that's assigning a string to it or something.
Okay,
Right?
so that was my understanding
Even
of
though that's technically callable.
Yeah.
But
I guess it's not argumented, but it is callable. Yeah.
no, but like
Python.
we shouldn't treat it as
Call it
like
string.
obviously like that would be treating like print or console log as a callable, right? Um, I think
Yeah, I may have
I'm
missed
checking to the right here. Well, this one's just checking that it's not.
just the lambdas. You're just
This
excluding.
might be wrong then.
Yeah, that to me that looks like it's capturing every variable, every constant variable, including const x equals 10.
There
Which
is not a specifier.
yeah, so that's what I was confused about. I don't think we
I
should
can't
do
remember the reason why I did that. I think it was because I wanted to capture in one of the fixtures.
if you want to just capture lambdas, you already have that logic, those rules in place.
Yeah.
You could just delete the constants rule.
I guess we don't want to capture this then, right? I'm
I
assuming.
don't think so because it's not unless it's callable.
I mean,
Yeah.
I think
you
it
might
technically
Well,
is. Like, you look.
what if we can I reference it in another class? Because then could be relevant.
Like you see here, like this is saying services.
Give me a sec. I don't know Ruby, so just give me a second to parse this.
Service.new.
Yeah, so we have service. It gets assigned here,
Okay.
and then does service.new, right? So
Okay.
it's an object, and then it calls execute on that.
I don't think services should be a definition. I think when we resolve the reference for service.new, we'll like capture that call and we'll backtrack when we're doing reference resolution to find what that's referring to.
Okay.
He's pointing to two classes, right?
So okay,
yeah.
so I see what you're saying. So don't try to capture this out of the gate. Well, this will be part of the reference work.
Yeah, this is reference work, I feel.
That's fine. I can update it.
Dumb question here, like how can we have a reference to something that's not defined?
It is defined.
Yeah.
It's just not the constant. It's a reference technically to the class that's inside the constant.
Yeah.
Right?
Yeah.
If I'm understanding Ruby correctly.
Yeah, I think that's what's happening here. Like it's getting defined, like the dependency is being defined here, right?
And because we have no runtime analysis, when we figure out the definitions that a reference points to, would we just point to both of those classes?
In this particular case, we might not even try to resolve it because of the runtime ambiguity.
Yeah.
I'm just speaking.
I mean, it depends on how advanced you guys want to get. I mean, we technically could, right?
Yeah, we'll just need like at that point we'll just need like a edge metadata that says like it's like a multi-edge, right? We don't actually know which definition this points to. It could be either or based on runtime.
You might want to even like think about having different modes, right? So like a shallow mode versus an in-depth mode, and like security would definitely want to know this.
Yeah.
Yeah.
You know what
I
I'm
think
saying? But like it might not be useful for an LLM, so we would have like a switch.
yeah, it probably won't be useful for an LLM just because again, we'll already have the high level kind of
Embedded in
relationship.
the actual, yeah.
Yeah, so yeah, that's a good discussion to have once we have the parsers and we kind of can start to figure out that general pattern and how we let like other teams extend it.
Yeah.
So yeah, for now we should probably not worry about it, I think.
Yeah, these are all different cases. I think in generally speaking though, like a definition should only be something that's callable. It shouldn't be a reference to something that's callable. Like if I have in Python, if I have def foo, that's my function, and then another variable x equals foo, I don't think x should be a definition.
Yeah, you're right. And the LSP doesn't treat it that way either.
Yeah. And I discussed this in this issue here. I linked it about aliasing. Like we might, instead of treating x equals foo as a definition, we might want to treat x as an alias for the foo definition, like add it as an extra property. Um,
Okay.
but that's a discussion we can have later.
Do you want me to add that to the definition struct?
I think for now it's not necessary.
And you want to introduce it in maybe Python or something?
Yeah, we can I can either do it right off the bat or like
We could put it under the metadata struct and just play around with it there first, and then
yeah, do that.
Yeah.
metadata option. Sorry,
But yeah, like let's say you have def foo and then x equals foo, and then you call x somewhere. When we do reference resolution, we will figure out that x is actually an alias for foo, and we'll like get the true FQN for that reference, and it would be foo.
Okay.
Yeah, all I'm saying here is like I think definitions should only be callable constructs. So if you had x equals lambda, a lambda, like an anonymous function or an arrow function in a JavaScript, then that should be captured as a definition.
We should write that down, I think, and
Yeah.
I can make a note of that to write that down.
Okay.
is the official definition of a callable something that can have 0 or more arguments? Right, that's something that can have
at least in
arguments.
Python.
Yeah, like
I don't know about other languages. In Python, it means it has the magic method call implemented on it, which is
I see.
underscore underscore call underscore underscore. I don't
Yeah,
know.
I think that's the same for JavaScript, right?
I actually don't know the
And then-
implementation details of JavaScript. So
in like in V8, like an object is always like even a string is an object, right?
yeah,
And it has properties. I think there's a specific property in like the V8 engine that designates whether it can be called or
Yeah, Python's the same way. Everything's an object, but not
Yeah.
all objects have a call method defined on it.
exactly. Yeah.
But yeah, I think just generally speaking, though, like functions, classes.
yeah.
Functions include like class methods and anonymous functions as well.
Should we make like you think
If
in
they're
the
named.
box like a definitions and then just explain what a definitions is?
Yeah, that'd be.
Yeah.
Okay.
Or we just put it in the one parser epic or something, or wherever you want to do it.
Yeah.
Might be language specific too. Like for example, modules exist in Ruby but do not exist in Python.
hmm
I mean, there is a concept of a module, but you don't define it in a file. The file is the module, or the directory is the module.
Yeah.
So maybe like per language, we just have a document like this explaining what we're treating as a definition. I think for me, I'll put mine just in the Python epic.
hmm Okay.
For Python, at least, it's going to be a function, a class method, or a named anonymous function. So if you do x
Yeah.
equals lambda, if you just have an anonymous function but it's not named, like you're passing it in as a argument for another function, for example, which is common, that I don't think should be captured because we can't possibly resolve references to something that isn't named.
Yeah.
Yeah. Also, I think for anonymous functions, at least named arrow functions in JavaScript, I'm probably not going to track them if they are like within the scope of another definition, just module level ones or ones that are specifically like exported and just used as a function. Because otherwise, like
Why is that?
you just get into like the whole data flow thing, assignment
Oh yeah, like
tracing.
that could be great. Like JavaScript is great. I can show you that all day. Like we have that.
Yeah.
I think we should still capture those as definitions. I think that's easy. But yeah, maybe when we resolve references, we decide not to worry about them.
Yeah. Yeah, that's what I did now. I'm just expecting that like there, in most cases, we will not be able to resolve
So you're
certain.
saying like here, right? Like imagine you have this method, right? This is all one method, and then I define a const, my const. Sorry. And this actually performs some operation, right, on like the data itself, like
Mhm.
event dot I don't what is this? On file change event. So like is trusted, right? I don't know.
Yeah, whatever.
Actually call this. You're saying don't track this, right?
I would say that because it's in the scope of another function, I mean, like, yeah, like you can track it. I mean, more so if you pull up the JavaScript epic for the JavaScript parser, I have it listed as like a limitation, the exact kind of like edge case that I'm talking about.
I think if you don't track those, you're gonna miss out on like a lot. I think, for example, some code bases only use arrow functions.
Which
I
one
think
is
if
it? Is it this one?
I think if you go to the actual like the actual description of the epic, that's where I have the
Oh, okay.
yeah, yeah.
Sorry.
No, you're good. Yeah, it's JavaScript. If you go to limitations, FQN resolution for anonymous function references, second one. So when you have like named like arrow functions embedded inside of a
Oh,
variable that can be passed around, there are many more cases to where it
I
will be
actually
very
got this.
difficult.
I got this working in my data flow analysis for does it throw,
Oh,
uh,
nice.
and that was a freaking pain. So I know we should do this eventually.
Yeah.
This actually is like a decent chunk of JavaScript code, right? But
Yeah, considering it's like a fairly well-established pattern. Yeah.
Are
yeah,
It
you,
should be
are you
tracked.
saying I totally get like ignoring this case, like the object keys, pointing to an anonymous function, but like what about just const my function equals?
Oh, no, no, that's fine. That I'm going to
yeah,
track,
You should
especially if
track
it's at like
it.
if it's at like the module level. I mean, that is like the canonical way to do it inside of like a JSX or a TSX file, for
Yeah.
but if
example.
you
I
have
think I
this,
think you should track it regardless of the scope, to be honest. And
Okay.
logic will be the same regardless of the
Yeah,
scope.
like,
exactly. Well, yeah, it'll just be
You'll still need a
retrieved by
symbol
AST,
table.
right?
You'll still need to keep track of all of
yeah, so like if you have this, right? And you have export const this, you still technically do this, right? In another file, JWT verify. And that's,
Yeah, unless it's like aliased, and then you have to track that. But yes,
but we should definitely, I think, track this
yeah.
later on. It's
I'm
just
just
Yeah.
saying.
a lot of AST work. So
Yeah, no, no, for sure. I'm just trying to be as intelligently lazy as possible so
yeah,
we can
yeah.
get this out. But
No,
no,
no, it makes
I mean,
sense.
yeah.
Yeah, but we should do this later on for sure.
Yes,
Yeah.
absolutely.
I
Yeah.
totally.
Um, okay, cool. Um,
Oh, yeah, I guess that clarifies some of my questions with Ruby, like about callables.
yeah. There's
How-
one case though here. I still have to figure out what these are. I actually should know that. But like these, I think are considered like attributes, but they're definitely used throughout the code base, um, in like significant ways. These attributes here.
I don't really know what
Um,
those are.
I'm not really an expert in them, but I know they're important for sure. Like especially in Rails projects. So you can see like root projects.
Are those variables or functions or what?
I think they're considered like attributes or something. Um,
But they're
I'll
not callable.
have to get a Rubyist to explain it, but
Yeah.
I've been trying to capture them. I just know that I think they are exposed. Um, it'll be definitely important to capture them in Rails projects. That I know. So like root project ID, I guess is a good one, hopefully. Yeah.
Yeah, I saw your attribute declarations rule.
Yeah.
I just don't know enough Ruby to understand that.
Like you can see here, like root project ID.
They don't look callable to me, but I don't know.
I think we'll want to capture them, maybe not as a definition, but as something else, maybe.
Yeah.
I can pull them out of the
This feels
definition.
like a macro or something.
Yeah.
Oh yeah, maybe it's a
It
macro.
has like that kind of syntax, but I've never written a
You
line
can
of
ask
Ruby in my
Kira right
life.
now. Uh,
It will fail.
um, 1 second.
Oh, and one other quick question, Angelo, about your PR. Like, and I put these all in comments too.
Yeah.
Just haven't written down, but uh, you're capturing do end blocks, right?
Hmm.
Um, but not all those aren't named, right? They don't have a name.
I thought I am only capturing the ones that would be callable. If I'm not, then I'll
No,
fix.
they are. Yeah, I guess it's technically callable, but like just like a lambda is callable, but not all lambdas are named, right?
It should be ones that are only do block, call. Yeah, not inside a lambda. Param, pattern block def. Maybe I'm not capturing it. I gotta make sure I'm capturing it. Is it good?
Yeah,
Is
just
it?
double check that because we want to capture callables that also are like named. Like you don't want it to be
No, yeah, you're right.
fully anonymous because then how could it be referenced? How can we resolve references for that if it doesn't even have a name?
I thought I'm handling that somewhere in here. What is it called again, dude? I'll look it up.
I saw your handling of lambdas looks right to me because you're checking to see if it's a lambda that's assigned to a variable, which makes it named and therefore callable.
Where is it? Block. Might not be checking it. Block def. Thought I was checking it. The thing is like it has to have a name attached to it. Otherwise, it shouldn't make it through. Otherwise, I'm not sure how I'm persisting it.
Yeah. Yeah, don't remember seeing any code where the FQN can be like null,
No, right? I'll
but
check. I'll check the test. Let's check the test. Event handlers block. Um, that's a good one. I'm not sure.
we can look into it after
Yeah.
the. Oh,
That I'll look into that and the attributes, and I'll solidify those
cool, yeah.
in the comps.
And
So
the constants, yeah. Okay, cool. Well, this all makes sense to me. I'm glad we have like an end-to-end code path now. You can actually
Yeah.
run the thing. That's awesome.
yeah, I mean it's not. That's one thing though is we need to figure out how to break this up. Um, I mean we could do the thing where we merge it and you know build off of that. I just don't feel comfortable doing that. The only thing is if we do it the other way where we break this into like 20 MRs, it's gonna take like 2 weeks. So
I think that given that like our team is quite small still and we're all communicating frequently, I don't see an issue with merging it as is
I think so
and
too.
building off that. Just because otherwise there'll be like 20 things in play and it's like just so much crosstalk and stuff. I think we
Yeah,
can.
I agree. I think we should just merge it and like sort of get something in there. And then now we've like established a pattern that the rest of us can build off of.
Yeah, roughly speaking, yeah.
And it doesn't have to be perfect as long as like
yeah, and my parquet stuff is really bad. Like Michael's gonna laugh at that.
No, no, no. It's again, as long as we get it
as it
in,
works.
yeah, exactly. it works end to end, and that's like the gold standard. Because then,
And that's what Tim's like really hammering too, is like
Yeah.
doesn't care about anything except, shipping speed.
Yeah, so that's what this is doing here. Like I'm redefining every property. Like I don't think we should be doing that long term, right?
yeah, we'll do like a mini DSL to do all that.
I
Like,
think a DSL would be really great. Like I was saying, like we define this. Like I'm kind of doing that in the GitLab research agent. Let me add that. I'll show you here. Um, and under Kuzu, this has the connection service and stuff, which is nice. But it also has like generic types. So if I go to infer node data type, so like just like Drizzle, in Drizzle you can like define a schema in runtime, right? We could probably do the same thing with Rust macros where we like define, we're gonna need to do this also for the Kuzu database too, right?
yep,
Um, but you see here, like I have all these different types.
yep.
So
I've written the exact same thing when converting like Postgres stuff to DuckDB before they add like an
DuckDB, okay.
adapter. Yeah. So yeah, no,
Yeah,
yeah, it shouldn't be too hard. There's a lot of patterns that we can use to
for
bang that
sure.
out. So,
And we should actually turn that into a library eventually and publish that.
hmm
People would actually probably use it.
Very bullish on open source. So yes, definitely.
Yeah. Yeah. So yeah, so that's basically it. I think I got through most of the code outside of we basically talked about the analysis step. So this is the analysis step is done under this analysis here and under mod specifically. So this just does like analysis for each file. It just iterates over the results. So it's just like an array, right? And then once it does the analysis, it writes it to a Parquet file under writer. And the writer is responsible for just generating all the Parquet files, basically, writing to disk. And then Kuzu is then executed under this database module. And this handles the connections here. So this is just all like the basic database management stuff. And then you can see I have generic things for like copying relationship from Parquet, and this actually builds the cipher statement. And once it builds the cipher statement, you can actually like execute that. And so that's what happens in this repository struct. So we do the analyzation, we get like the results back, right? We get the graph data struct. We then write it. I then write it to the Parquet files, and then we load into the database with this method here. So we just call this, and this method actually loads up the database, blah blah blah, and then runs this import graph data. And this import graph data does all the steps. So first it imports the nodes, then it imports the relationships. This is going to get complex though when we start to build out real-time indexing, right? So user changes a file, we need to execute cipher statements, right? That's going to be something we'll need to handle later on. So there's that, and I think I scoped it as a repository, right? Because we're working mainly off of repositories, but I also thought like maybe people might want to run it in non-repository environments. But like repository, I'm just thinking like we could keep it this way because then let's say we want to pull in Git data and index Git data as part of the graph, then it's everything is in the scope of one project. But it might make sense later on to like think about different ways, different type of structs and like project structures and
Yeah, I think once the rest of us start contributing to the indexer,
yeah, it'll look yeah,
we'll learn more of the structure and have
Yeah,
like more opinions on.
yeah,
yeah. What might be the best is that if the working Ruby parser gets merged into the one parser and this also gets merged into main, and that way we just have an end-to-end snapshot that works, then it'll be really easy for us to
yeah.
You just all test it end to end.
Yeah.
That way we can merge our PRs too to
Yeah.
for the parser.
Yeah, and then the only other thing is I created a little small utility for like running it in dev mode. Because we have 3 different projects, right? So I'll get the code cleaned up. Where is it? Is it a cargo command? I should make it a mise command, but oh, I made an X task, sorry. So if I go under here and collapse these under X task, I added just like a thing. You guys will see it when you try to run it later on, but like let's say you were making code in the change in the parser and you want to make a change in GitLab and then like just have it work locally like npm or I don't know how Python works in that way, but this you just literally run like cargo run x task set mode to local dev, and this will create a small cargo file here, config file, which will point to the local repositories. So and that's basically all you need. Like the rest is like handled by Rust, which is like, man, coming from JavaScript world, that's like such a godsend. So but yeah, that's pretty much it.
Cool.
Hopefully, makes sense. I got my action items.
Same.
Yeah.
Same here.
Same. Anything else?
I think that's it. I think like on my end, I'm once the Ruby stuff's merged, I'll merge in the definitions and imports work for Python, or I can get a quick review on it first.
Same.
And then after that, I guess since we're still in phase 1, I think the next step would be like helping with the indexer side of things.
Yep.
And yeah, then we should probably sync up for that, and Angela can just put us to work.
Yeah.
Whatever you need.
Yeah. Well, we have all the components of the indexer, and then one of the last pieces is that I'm trying to set up is connecting it to workflow. And so I want to spin up the node executor on the language server and just write a simple tool to get that all working end to end.
Mhm.
And then we have a fully working end-to-end knowledge graph,
Yeah, that'd be awesome.
Which is wild. Yeah.
which would be crazy. Like,
Yeah.
I mean, it will be like the jankiest thing on the planet, but like,
And it won't have any edges, or no, it won't have any reference.
yeah, it has no it's like
Yeah.
kind of useless in that way. I mean, it's not useless, but it's non-functional for sure.
It's not useless. Like, I actually think it's kind of useful for RAG.
The
Yeah,
definitions
definition.
itself, you think?
Yeah, I think it could be like for massive files.
For massive files and for massive code bases, for sure.
Yeah.
Like having this for the monolith is like next level.
Yeah, it's not totally useless for RAG, but obviously way more useful with references.
Yeah.
Hard part, but
Although if you combine with full text search, you can do a surprising amount of cool stuff. Like in RAG, even though you don't have references, you can essentially have the LLM just come up with queries and pull in a basket of definitions and still
like
be able
that.
to.
Like that inheritance thing you were showing off, Angelo.
Yeah.
Captures class. So that's a good example.
And so that's what I was gonna say to Bogdan, like your question is like, how are we gonna implement it, right? So we have the database file created, right? Then what we're gonna do is we're gonna write a query service on at least for the client side. The monolith is gonna look a little different, but on the client side, we're gonna write like another Rust query service. It's gonna have predefined Cypher queries for executing against the database, like the ones I showed you. So like find definitions for this module or find XYZ or whatever Cypher queries we think will work best. And that's what and then we can even have a generic Cypher query like BFS, right? And you can just give it like here, you can give it a node and it'll do a BFS and it'll look at all nearest stuff, right?
Yeah.
And you can just give that to an agent and the agent will just re-input as it traverses the graph.
Yeah.
And then you're like, that's the product right there.
Yeah. I like the idea in general of like not having the agent explicitly write cipher queries.
Yeah, I don't think it's going to be good with Kuzu either, just because Kuzu syntax doesn't fully implement Neo4j. So in my experience, like I'll have Claude generate a bunch of cipher queries and they'll all be wrong because they use the Neo4j syntax.
Better
So,
to like not risk that and to put queries behind like a tool layer.
yeah.
Yeah.
The tool
And
layer.
it'll be faster in that way too, because
Yeah.
the LM only has to generate JSON versus the full cipher.
Yeah. But yeah, either way, it's all great. I'm glad got something running.
Yeah.
10 seconds is amazing.
Yeah,
Yeah, 10 seconds is crazy.
Optimizations. Sure, we could make it even faster.
for sure.
So
Yeah, this is like very little optimization. It'd be crazy if we like optimized it and got it even faster.
yeah,
At that point, like I feel like if it just only takes 10 seconds, like maybe we don't need to build incremental indexing. Like maybe we
possibly,
True.
yeah.
You just reindex everything. Yeah.
just like
Just
I
to
don't know,
start, we
periodically reindex everything or like debalance it, reindex everything. I don't know.
yeah. It'd be nice if we can avoid that. It is a pain in the ass.
Yeah, definitely.
Yeah.
So
Well, guys, all right, I'm gonna run and like get back to coding. But
sounds good.
Yeah.
Cool.
All right,
All right.
guys.
later.
All right.
See you guys.
Bye.
Thanks.